Is everyone fine with their power for now?
I think I'm good. I have so many tabs open. Okay, so what we covered last time, let's do some recap probably by the time other people, if they're coming, we can talk about them later. So this is the fourth session, sorry. Where's my mouse? Yes, so this is the fourth session, and previously we covered about the networking aspect. So we have looked into the identity component, we have looked into the organization aspect of things, and last time we looked at the networking foundations. What we are covering today, so it's a build-up of things. Now what we are looking into is the private services. How do you make sure that when you are talking to cloud or talking to different services, how do you make sure that you are in the private network only? So that's the main idea. We will talk about different services. There in this session, previous to this, like in the last 2-3 sessions, the topics were very generic in that sense, in the cloud generic way. VPCs exist everywhere, IAM identities exist everywhere, service accounts are everywhere. Now, this time, what we will be talking is, I guess, very specific to Google Cloud in some senses. Hello. Yes. So again, I'll give a brief overview of what is happening. So we covered in the last 3 sessions the very basic of cloud services, but this time what we are covering is very specific to Google Cloud. That is, in previous sessions there was like identity services and other organization services and service accounts and whatever was related to the IAM principles, and some bit of networking, which was the last session. I'll take a recap of what we did last time, but the idea was that whatever topics we were covering were very generic. Now, the services, in a way, it is like 50% still same. Azure also provide a lot of services that allows you to connect privately to your virtual machines, and similar way AWS has it, and similar way GCP has it. But there are a few services that are very GCP native, and I think some of them are really, really powerful. And to my understanding, I haven't seen them in Azure or in AWS, so we can look into them. So let me give a recap of what we did last time. So we looked into what VPC are, what subnets are. VPCs are the highest level of isolation in terms of networking. And then subnets are basically smaller network inside the VPC itself. VPC is a private cloud. It by default does not expose your resources to the internet. It's a private by nature. Then you have default VPC trap, that if you use the default VPC, it comes with its own security nightmare of like having certain protocols enabled. So your RDP is open to the whole internet, your SSH is open to the whole internet, and there are some custom modes that you can change, but deny all problems are there, right? So basically, there are the default should not be used. You should be creating your own VPC, because when you create your own custom VPC, it comes with default deny, and then you can start building or whitelisting whatever you need. Stateful firewalls situation, that is inbound allow automatic permits. So it's deny all and allow all rule problem again. So you can, when you're creating a custom VPC, by default, everything inside is denied and everything outside is allowed. So you can change it to deny all from the egress perspective, and then you can whitelist whatever you want. And there are targeting rules, like specifically the service accounts. When you are doing firewall rule creation, you can say that any VM or any virtual machine that is using the service account is allowed or not allowed. So this is how you can map, or you can use tags. Service account is one possible option. Shared VPC is somewhat a new concept for Google Cloud. It allows you to have like a VPC that is shared among multiple projects. So let's say there are 2 or 3 different projects, and you create a VPC. That VPC is shared across multiple Google projects. That's a shared VPC concept. The last is VPC peering, which is across all of the clouds. You can connect one VPC to the other VPC, and you can connect so A to B and B to C, but there is no A to C connections by default, right? So if your transitive dependencies are not there, that is, if you connect A to B in VPC peering and then you connect B to C, that does not mean A and C can talk to each other. You still need to connect A and C. So that's a VPC peering concept. So what we covered last time was very fundamentals of networking in cloud. I think it is a really important topic. If you did not go through this topic previously, I will say go back and have a look at the videos. We have recorded, we have the slides, because it doesn't matter. It's not just from the exam point of view. In cloud, you are dealing more often than not just with 3 or 4 main domains. That is compute security, that is your actual virtual machines or Kubernetes, or IAM, that is identity access management, service accounts, principal identities, whatever, machine identities, and then cloud networking. So these 3 or 4 made up the main important cloud infrastructure. And because I have exposure in working on the AI infrastructure side of things, it still remains the same. Doesn't matter what you're working on, you will end up working on these same things again and again. With AI, this is coming more on the application level, but cloud is securing the infrastructure. So even if you're running one of the best AI models, you will still end up securing your infrastructure. So this becomes a foundation. That's why, at least what I have seen in the last 1.5 years, is a lot of jobs in security market are changing, but cloud security still remains very relevant because it's the infrastructure that on which you are hosting AI. So it does not go out of the picture as of now. Let's see how long it will be, but for now it is there. Okay, so like I said, this time or in this session, what we're trying to do is basically see the evolution of access in such. So we will look into how we were doing access provisioning or access management to your virtual machines previously, and then what is the best version of it, and how did we go from public to the private segment, and what is the best option to go towards the private segment itself, right? So legacy, the most obvious one is basically you assign a public IP address to your virtual machine, VMs, computes, whatever you want to call it, depending on which cloud provider. But this is a very classic behavior. You assign a public IP address, and then you open up SSH or RDP port. That is how you connect, and you basically connect to your machine. The problem is, because it's open to the internet, it is open to internet trying to access it, trying to brute force it, try to connect it. So it's on the first step, written as insecure, and by the default nature of being security, people will be like, yeah, no one do it. Trust me, I just handled this today. So it doesn't matter how insecure it is, you will definitely find one or the other person doing it. The next is the traditional bastion host. Again, written traditional, but if you go to any startup environments, in fact, in very big cloud providers like cloud or big companies also, I have friends in like Big Fours, they also share the same stories. This is a very common pattern. This is not like a dinosaur era situation. Maybe people know that you don't assign the public IP addresses, but bastion is a very common concept as of now. The concept is very similar, very simple. So let's say previously we were talking about virtual private cloud, which is a private internet, whatever you call it, like private network, right? So you create a machine inside that private network, and you connect to that machine, and that machine can connect to anything inside your network. So that's a bastion host on a very simple note, right? What does it look like? A simple virtual machine. It's a simple virtual machine / computer / whatever you want to call it. But it is exactly the same thing on which you are running your application or a web server. It is exactly the same thing. It just does not connect. It's the only point which has connection to the outside, and everything inside is connected to this machine. So you basically log on here, and from here you jump onto the other machines inside your network. So that's the idea of bastion host. People call it jump host also. It's very similar, same thing, but different terminologies. Obviously, there's a problem with it. Anyone wants to give it a shot? What's the problem with bastion host or jump host?
If that gets attacked, everything.
Yes, precisely. It becomes a bottleneck and a very important point, right? Because it's exposed outside to the internet. This is where all of your company is getting connected to, and that is how you're getting access to your rest of the network. So this become that one point. If you compromise the rest of the network. And one other side of it is, I said it's very similar to what you host your applications on. So it's a web server slash computer slash virtual machine, whatever you want to call it. So it has a whole operating system, it has applications, it has dependencies, it has libraries. All of them get outdated over time. So the more you have a full operating system, more chances are that it will get outdated, more chances are it will have a vulnerability that can be exploited, and it is publicly facing. So there's a chance that it will become vulnerable, and if you don't really monitor it, it will become the point of compromise.
Can you restrict its access?
Yes, you definitely can. That's the whole idea. So I don't know how many of you have heard this term, demilitarized zones, DMZs. Yes. So the idea of it was always confusing to me, the idea of DMZ, like what do you actually put there? Do you put your web server? Do you put your load balancers? Do you put your like actual private data or whatever? So because it's something in between which is not public but not private. So that is the definition of DMZ, something which is not like facing the internet but is facing on the other side, it is facing the private network also. So what is the actual machine that sits in the DMZ is actually a bastion host, because on one side it faces the public internet or you or us, and on the other side it faces the private intranet, right? So that's the very good definition there. So you can restrict access to it, you can have identity management on it, right? So no one is saying that it has to be public. That is a necessity because that is how you connect to it, but no one is saying that you just need, if the IP address has to be public and there needs no authentication. You can add an authentication layer to it, so you can control access to it. You can have a whole application running on it which authenticates you, then decides where you can connect. I forgot the name of it. Citrix servers, if anyone has seen. Yes, it's a very similar to like a jump host situation, but in a much more complicated manner, because when I say jump host, it's a plain simple operating system and a plain simple virtual machine. With Citrix, it's an application sitting on that, controlling the access to each and specific application. We'll talk about it. It's an interesting thing that is now being used. But yes, whatever we are talking is kind of outdated. We should not be using it, but yeah, we do. Enterprise VPN and interconnect is where basically we are having encrypted tunnels. Simple as that, VPNs. Everyone would be aware of it. If not, it's an encrypted tunnel between one side to the other side. Now, what is on one side or the other side, it is up to you. It can be my phone to the laptop. It can be my company to the other company. It can be my company to the private cloud or the cloud provider, or it can be my company to the other, like my own home office, right? So it depends what you're doing it, but the idea is there is encrypted tunnel between one point to the other point. So if you share the data in between and there is a man in the middle, technically there cannot be man in the middle, because encrypted tunnel are not supposed to be broken, right? So that's the whole idea of VPNs. What's the enterprise component of it? When you connect one company to the other company, or basically when you connect your cloud provider to your company, right? It's a very common pattern. You will see that happening. It's a little hard to set up. So what startup end up doing is that they will use public IPs. At least that's what my exposure has been. They will start with a public IP, then later on when they will end up realizing that, oh, we are getting a big client and now they need 27001 compliance or whatever, that they will realize that, okay, we cannot use public IP anymore. Let's move on to jump host. They'll go on to jump host, then SOC 2 will come in. When SOC 2 compliance will come in, then they'll be like, okay, we cannot use jump host anymore, or jump host is a trouble. We don't have the IT team to manage jump host. So they will end up with this option. But that is where the first security engineer is hired. So
Public IPs are GCP's public IPs.
yes, yeah.
Can you bring your own IPs?
I don't have answer to that, I think, but I don't think you can. I mean, you have static IP assignment, but I don't really know if you can bring your own IP. You definitely can have a static IP.
I think you can, in my company, they bring their own IP.
Yeah, it makes sense. They should be able to do it because a lot of providers are very static in their IPs. So
Yeah, they have their own ranges, and the customers want only these IPs from the company.
Yeah.
okay, yeah. Thank you. I wasn't aware of that.
I did the part where you said they bring their own IP.
So cloud provider has a pool of IPs. right? That you can pick
Some
from.
are public, so it gets allocated dynamically.
Yes. So what we are saying is that, let's say me as a customer is having my own IP that is not part of Google Cloud pool. So can I bring it to the cloud and be like, I want to use this?
So the
They put a range of IPs, for example, from 65 to 100. So this range only belongs to that company. And then
so the
you can-
private ones that are already bought by the company. Those
Yes.
ones? Okay.
Maybe it's more like you can bring your own IP, but you need to set up it on the DNS that you have in the cloud.
Yeah.
Like you can have IP, then you set it up in the domain name DNS service, and then you can access it anywhere.
Yeah.
And you have to add it to the GCP so that.
It won't be added to the GCP pool.
It's an interesting question. I'll look back and maybe I can figure out what happens. But yes, you have the option, I think, to bring the your own IP addresses. The last bit, but that is the modern zero trust. Now I can do this session in 2 or 3 different ways. I can run like I was running previously, like cover, and then there is this, because this time we are going to talk about very specific GCP things. So what exam is going to what exam wants from you is that you remember the name of the service and that what is the specific configuration that you need to do. But there is a lot of background security or reasoning or logic behind it that we can talk about. So it can be more conversational, or it can be more covering the GCP side of things. So if you guys want to cover certain things, let me know, I'll go fast. But I want to give you the background of it because to me, that is the most important part here, right? So anyone wants to help me understand what zero trust is? It's a very interesting concept, theory, marketing term. So anyone wants to give it a shot?
Marketing.
Yeah, now it's,
Coming in more reality.
oh yeah. Anyone wants to give it a shot of what is zero trust? What do you understand by it?
Zero trust on the
Never
user.
trust all.
Never trust, always verify. Okay.
I was just use the example of, say, bouncer. And every time you go to the door, they always go, "Who are you?" Even though they've seen you
Yeah.
like 5 minutes ago, they'll
Mhm.
keep asking you why.
Yes.
So it's just you need to keep refreshing it almost.
Yes. That's a very good way of explaining this topic. Anyone else want to add anything to it?
I could talk for hours.
Oh yes, it's an interesting topic. Okay, so I want to share some story from my exposure here. So my first job was in IBM. Back then, zero trust was a buzzword, and IBM wanted to be the company which was like, okay, we are selling zero trust, so here is Ashish who's going to do it. So what ended up happening is that there were many providers. So for example, there is Zscaler, there is Netscope, there is like multiple providers that came in. Like for example, right now you are seeing multiple AI companies doing similar things, but packaging in different ways. Same way there was zero trust coming in. So that time the theory was that you bring in one tool, you put it in front of your company, and then you're zero trust. Basically, we do the verification, we do the assessment and whatever. From then, that was like 2020. It might have existed before that, but that's my exposure to it. From then to now, the industry has really evolved in this term. And at this point, if you're not doing it, you are actually kind of leaving a lot of security flaws. And I'm not kidding when I'm saying that firewall security or perimeter security is gone. It's actually gone. If you're doing it, you're in a real problem there. Because threat actors have AI. If you're not doing it, you really are going to be in trouble at some point. Now, what is the current definition of zero trust? It is very different from different providers and different people perspective. To me, it is 2 different segments that put together. One is the network security controls, and the other is the identity control, right? The theory remains the same. Don't trust, always verify. That is right. So you do not trust and you always verify. So what's the idea behind it? So like what you just explained, Sarah, similar thing that let's say I'm trying to access the application. I just access 5 minutes before. I don't care. The firewall or the application does not care. It will verify again. Not just 5 minutes. I'm not talking about 5 minutes or the duration. I'm talking about every single request that I'm sending. It has to be verified again and again. So that is ACL-based access control list-based access. So this particular thing can do this, but every time it is sending a request, I'm going to verify it, right? So this is the identity component of things. And then there is a second pillar of it, which is a network component of thing. So why is an application who is in a private network from customer X trying to access something in the private network from customer Y. It does not make sense, right? So there is network segmentation. So you build the network segmentation, isolation, segmentation principles around it. So network security controls around it, right? So you put firewalls, you put, again, similar technologies that we were talking about before. Network access controls, firewalls, IDS, IPS, all those kind of things, like the network layer. Then over that, you put an application layer, which is going to do the authentication, authorization component again and again, right? So, and I mean it, when you actually try to implement the zero trust, this is where you will realize that you don't really need a vendor. At that point, I was selling zero trust by the name of Zscaler and Netscope, that, okay, this is the only way you can do it. At this point, when I'm doing it myself, I don't think we need it. It's just you investing time in designing your architecture in a way that it actually does it. For example, if you do it inside Kubernetes, Kubernetes has it done already. So like you can have service mesh, which does this every single time. So I don't want to throw big words here, but it's basically Kubernetes is the orchestrator of an application. You add a plugin to it, and this plugin takes care of it. Every time one service tries to talk to other service, it will make sure that it has valid certificate. It will make sure that it has right principles in place. It has right attributes in place. So this is a default plugin now, and you don't have to pay for it. But on the other side of it, you can buy the whole really zero trust suite and whatever. And why I'm explaining this whole vendor perspective is because as we will go on to the session, you will see Google try to sell it their own version in this session itself, because they have their own zero trust way. But I want to explain it from the infrastructure perspective, or how would you build applications around it, rather than, okay, just plug it in and you're zero trust. That's not the case.
I just want to add one thing. With the zero trust, one of the good things is it's risk-based approach every time there is a request. Like if I did log in from this computer, from this room in 5 minutes, it will be an easier process with the zero trust. But if in 5 minutes I try to connect from Russia, then that's a different risk profile, and it will say,
Yes.
nah, not on my watch. So those engines are important, those policies, setting those risk stuff, which wasn't easy back then, but now
Exactly.
I can
Yes.
see there's more products that come with it as like natural.
What just Didar said is something in GCP called Context Manager. It's a service in GCP. It's called Context Manager. What it does is, when you send a request, it will take the context of your request. So where did you log in from? Is your laptop compliant? Were there any patches missing on your laptop? Is it corporate IP profile, or have you authenticated? When did you authenticate? Which is your IP? All that is context of the user who is going to access, or the application, right? So this is context. There is a service in GCP which we'll talk about, and it's exactly this, that whenever you're sending some information, it will collect all your context, put it against your application, against your request. And when you send this request, there is a rule-based engine which decides that, okay, I have whitelisted, as administrator, I have whitelisted that if you're coming from corporate profile, your laptop is compliant, and you are in UK, you're good. Otherwise, you're not. Any of that context is missing, you're out. It was really hard to implement back then, because if you were trying to do this before, you would have had 5 different tools collecting 5 different context information, right? One particular tool collecting IP information, geolocation, then your laptop compliance report, then your outdate report, and blah, blah, blah. Now there is just one tool collecting everything, and then there is one tool which is basically checking it. So now the implementation has been easy. Now, if that is the reason why, if you're not doing it, you're losing out on actual security benefits. Tools.
And one more thing, not about zero trust, but big corporations, where we found ourselves is, as identities become more and more important, we found ourselves with multiple identity providers now. We use cloud native ones, we use the ones that are very expensive, and we use multiple of them. And now it's very hard to go back to basics, and it's easier to start now from scratch than what corporates ended up being with multiple different things that you need to manage together.
Oh yes, so this was the major chunk of zero trust projects that we are getting in IBM. That is migration from current chaos soup to one single identity provider. and put it like zero trust based. So this was like the transition is the most chaotic part, because now you have to restructure your whole network. Then you have to make sure identities are checked at every single point. It's a big problem. But if you're starting from scratch, this is probably your best bet. Again, it's a very interesting and big topic. If we keep talking about it, we'll probably not even go to the next slide. So, and if my cursor goes to the other, yes, it does. All right. So, private Google access. What is it? Like I said, in this session, we are just going to talk about different ways that you can connect to your workloads, your machines, your services, your buckets, or whatever, in a private way. Everything is just about making sure that you connect it in a private way. And my personal opinion, Google has done it best. Anyone can come back and have an argument on this, but I think my exposure says that they have really good options there to actually make sure that you'd never actually make your things public to the point you don't want to. What is private Google access? Simple idea. Your any services that you are accessing on Google, for example, bucket storage or virtual machine or IAM, they are behind the API, and there is an API address to it. So for example, for bucket, so it is bucket.google.com, right? Bucket api.bucket.google.com, same way, right? So this way, there is like every service that Google has, and this is not just Google, this is all of the cloud providers in general. Azure, GCP, AWS, everyone is basically clubbing all of their service behind the API. So when you are creating a bucket, when you're creating a virtual machine, you're basically going to that API, sending some configuration, asking the provider to do something, but you're basically interacting with that API. In the first session, we covered this, that there are 3-4 different ways of actually interacting with the cloud: CLI, UI, SDKs, user interface based, CLI based, SDK, like code based, but everything at the end of the day talks to an API. Now, what we are doing here is, what private Google access does is, as a normal user, like you and I, when we are trying to access it, we are trying to access the public APIs, right? So if you look at the this part, private.googleapis.com. So when we are using public.googleapis.com, right, as a normal user. So what happens is, when you are creating, let's say when you click that create a bucket, your request goes via the internet and gets redirected to this URL, and then from here it figures out what is the specific request that is like bucket, and then inside that it goes and do the configuration. But essentially, when you are a normal user also, you are going via internet, right? So let's say I created a virtual machine inside my network, inside my private network, and I try to access bucket api.bucket.google.com. I won't be able to access it because this lies on the internet, right? And I haven't given any public IP to it, so it cannot route the traffic to the public internet. So it will fail. Now, how would you solve it? It's a one simple toggle. Maybe I can show. Yeah, it's a bit complicated for me to navigate from here. Anyways, it's a small toggle. After this, like once we have covered the theory, maybe I'll go to the console and show you where it's done. But it's a simple toggle. You go to a subnet and you enable like one single button that says private Google access is equals to enable. What happens is, now you do not need a public IP. Your machines, any virtual machine that is having just a private IP, you never attach a public IP to it, always private IP. And all of a sudden, it can figure out all of the Google APIs, all of the Google services, right? How does it do that? The Google has basically exposed its native services in 2 different API formats. One is public and one is private. So when you enable this particular toggle, that is private Google access, it just enables this private.googleapi.com on your subnet. So your virtual machine does not need to go to internet. It can directly reach this APIs through the Google internet internal infrastructure, right? You just enable this. It's an internal DNS routing in a very simple way, right? Google already has it. They have an internal version of it. They just expose these IPs to your virtual machine when you enable this.
That should be in one network, or it might be in another network. In one private network and another private network. So
yes, I think you're confusing it a bit here. So when I'm saying you're not trying to access a service from one VPC to the VPC, you're trying to access a service of Google. which is a global thing, right? So there is no VPC to VPC communication here. You're just going on one VPC, or let's say you have a network, you deployed a virtual machine here. Now this virtual machine wants to talk to Google. So how generally it will do is it need a public IP and it needs to go to internet, and that's how it talks. But now you don't need a public IP. You just enable this particular toggle, and now Google internally is exposing everything to this, right? Yeah, it's a global network. Global Google network is exposed to your virtual machine. So just when you enable this, you're not able to go to google.com, you're not able to go to facebook.com, you're not able to go to any of the malicious IP addresses or anything. No public access is still there. You're just able to go to Google services through Google internal URL domains, right? Make sense?
But to access the actual internet,
You still need public IP as of now, because we haven't talked about other services or other configurations. But it's a really important thing. And let's just think about from the practical perspective. Now, me being a cloud security engineer or cloud engineer, whatever, very more often than not, I will have a database, simple 3-tier application, right? There's a front end, there is like middle tier, and then there is like database tier. Let's not talk about the first and two, because they are meant to be public and semi-public, but the last one, the database. The database service that I'm going to use is a Google native database, PL/SQL. It's a PL/SQL or like PostgreSQL or any of the Google native databases. They are internal Google services. I'm going to use them. There is no reason for me to enable public access to my database, right? And databases are the main point where we are storing our main crown jewels. Why do we have to give them public access? If the only thing that they're going to talk to is the middle tier, that is like after front end, there is like a middle tier, let's say some Python code or whatever, that thing is going to talk. And the other thing that database needs to talk is internally to Google. Now, these are the two only use cases for at least a normal application. Now, in this case, why would you want to assign a public IP to it? You do not. The problem is people don't know that there is this option that you can expose Google services internally with just one toggle. If you know it, there is no need. If you're going to just use the Google services, there is no other requirement. Just enable this. You have essentially removed all of the attack exposure that can come from the internet. You don't, again, a personal work story. I can't mention the company name here now. A very big bank. They were running 2003 Windows Server when I was managing their endpoint security, right? And they were banking servers, the actual ATM servers, 2003 Windows, right? And they never got attacked. I was so surprised. Like, they never got attacked. The only thing that they did right was they kept it private. They never connected to the internet. Everything was behind the private network. So essentially, you can run super chaotic things in your private network. No one cares because you never connected to the internet. So this is what you're doing right now, right? Now there is like a little problem here, and from the attacker perspective, this is good. I'm no way saying that don't use it. It's pretty good. Always use it. This is by default. In my case, this is first thing that I go when you want to highlight your name as a cloud engineer, cloud security engineer, and be like, okay, you have done security wrong. You basically go and you're like, oh, you're using public IP. Let's make it private. This is what you do. So it's very like low hanging fruit. Just you change it, all of a sudden you have removed all the risk. So this is a really good thing to do. From a very attacker perspective, this is still not enough. Why? Because essentially, your database is going to talk to Google buckets, right? And let's say this Google bucket is attacker's bucket. So you are not actually controlling which bucket. You are saying you can just talk to Google services. Now, who is stopping an attacker to actually host their infrastructure on Google? No one. Yeah.
How does Google give access to these like five?
It's an internal networking that they have done. That's where it will get, like, the more we will go into it, more it will become clear and confusing, both at the same time. But the idea is that Google has done internal networking, and it allows you to access its services. If you're on the same infrastructure, Google infrastructure, it allows you to access its own services through private internet, through Google itself, right? This is what we are essentially doing by enabling it. But at some point, we'll go and actually whitelist certain IPs from Google to actually enable. We'll get to that. I don't want to confuse you right now. But in the MITRE attack framework, if anyone of you have heard it. MITRE is an organization that tried to collect all of the attack situations from different threat actors in the whole world. A very, very interesting and one of the most used data exfiltration technique, like to exfiltrate the data from your network to outside, is using a cloud provider's storage system, right? Because how would you block or how would you control access to cloud provider when your whole infrastructure is on cloud, right? So it makes sense. Let's say I'm on Google Cloud, I will block Azure storage, I will block AWS S3 buckets and whatever. If I block GCP storage API, my internal services will break, right?
So what was the name of the company? Mind and?
MITRE, MITRE.
MITRE.
Yeah, it's a black hole of itself if you go in there.
Oh, okay. So I was reading it as Mitre. So
Yeah, it's I was doing it too. Then
We've had sessions on it in the previous years, but I'm not sure if we put them on YouTube or not.
it's an interesting place if you go as a defensive person or as a engineer, security engineer. I rarely go to it, but if anytime I go to like CTFs or anyone I know is doing pen testing, it's a very important thing for them because this is where you go and see what other people are doing, right? So a lot of security engineers would also not agree to it, but for now I think it's fine. Okay, let's go to the next. So this is the main idea. This diagram is a little short, so I'm not going to explain it because
like Azure and AWS don't have this feature.
no, this one is everywhere. This is a constant feature. AWS also has it. Private Connect. What's it called?
VPC endpoints, gateways.
VPC endpoints and gateways. They call it, AWS call it VPC endpoint and gateways. Azure, I'm learning. I'll let you know in some time. But other providers have it. This feature is there. Yes. See, at the end of the day, every cloud provider competes with each other. So even if AWS has GCP has done it, AWS will have to do it. Otherwise, people will leave. So they will end up copying it maybe in 1 or 2 years. But there is very specific service, which is IAP, Identity Aware Proxy. I haven't seen it anywhere. That's a very GCP native thing. And there is VPC service controls also. This is also very AWS specific thing. I don't want to confuse you right now, but sooner or later we'll go there. And when we reach, I'll tell you that this is very GCP native and no other cloud provider is doing it. But this one is almost available everywhere. The names might change. I don't want to explain this diagram. It's a little wrongly done. But if you look at this idea, the idea is that this is your private virtual machine. There is no public IP to it, and the request is blocked, and you cannot reach the Google APIs, right? So this is the main idea. Now, this is where I didn't want it to explain why. So this is your private virtual machine. This is your public IP address. It tries to reach out to another service, and now it can reach, but it is written that Google internal path. Yeah, that is basically using Google internal network. It is able to reach, but where it gets confusing is where it's written Google public API and Google public API. It was a prompt to Gemini, and it created chaos. So
Is that request from Google API?
no, that's it's not. It's just me writing the wrong prompt and giving the wrong diagram.
But that connection, is that like an encrypted?
It's an internal connection. It's not going via internet.
Like a tunnel.
Yeah, not a tunnel. It's not. It's an internet. It's an internal network, but it's not encrypted. No.
Traffic is going somehow, right?
Via internet, via internal network of Google. So essentially, because your VPCs are private network hosted inside Google, so Google can connect its private network to anywhere you want. VPC peering is doing the same thing, right? We talked about VPC peering last time. You connect one VPC to the other VPC, and then you're able to talk to one private IP from here to one private IP from here. Now, what you're doing is basically you're taking your private IP virtual machine and connecting it to Google's private network. Right, that's the logical way of understanding it. They have just their own virtual private network with their own private IP addresses, and you have just made a VPC peering.
There could still be encryption or authentication.
Yeah, there could be for sure. Yes.
There isn't.
I mean,
We don't know.
yes and no. By the there is compliance. I forgot the name of the compliance, but cloud providers are mandated to have encryption in their internal network also. So by the nature of that compliance, I'll say yes, but there has been cases where they haven't used it. So depending on like big cloud providers, they will definitely have encryption internally, but maybe not always. For Google, yes, it will be encrypted in some sense. I'll change this before I give the slides to you, but the idea is very same, that instead of Google public APIs, it's Google private APIs. So it goes via the internal network. Network address translations, NAT gateways. Anyone heard of it? Anyone wants to explain it? Neither knows it.
So this is like, you have your internal network IPs usually start with 10 dot something, something, something. But then you want, like this machine, when I'm on my corporate network and working with the Outlook server or something, it uses 10 points something, something, something. But I also want to be able to access the internet. So I go to the router, and the router does something called the net. So it translates to one of our public IPs.
Private.
So,
Yes.
Private
public.
IP? What?
It's called,
Anyway, it
yeah,
translates from 10 dot something something
to a public IP. Yes.
a public IP.
Yeah.
So that I can be on the internet,
Yes.
and vice versa. If there is something sending a packet for a device within the internal network, that translation also happens. And reverse.
Yeah.
And this solves the issue of IPv4, where they were worried that there'll be a lack of IPs to allocate to other people. So they came up with this as a solution to that.
Yes. Smarty.
But IPv6 never took off.
Uh,
We found ways to get around.
okay. This is exactly what Deidre has explained. If I try to explain it in a normal human perspective, so let's say we are sitting here, my friend Ujjwal, he's standing there, and we are like, okay, Ujjwal, get us a coffee. So Ujjwal is the NAT gateway, right? So the coffee machine never sees me because I'm in the room, I'm in the private network, so they never sees me. They always see Ujjwal, and Ujjwal knows who to come back to, who asked. Ujjwal has this mapping in his head that Ashish is this guy, and I need to send him, and probably not give coffee to him, but everyone else. But yes, this is a mapping in his table, right? So NAT gateway is basically doing this mapping of who sent the request and where do I have to send the response back. This is capped by the NAT gateway, but as a machine or as a user, I never go out. On my behalf, NAT gateway goes out, it does the communication, comes back. By the nature of it, NAT gateway has to have public IP address because NAT gateway talks out, right? So it needs to have a public IP address. What is the most possible use case of doing this? Where would you imagine using a NAT gateway? The most obvious one.
I have so many assets in the network. I don't have enough public IPs to assign.
Okay, that's a good one. Yes, 100%. Because if you assign public IP to 15 different machines, then all of a sudden you will realize you have 1,500 machines. How many IPs you will assign? And there is a cost to public IP addresses. So that's just obviously a reason. Anything else?
Want to update your private machines?
Yes, this is very, very important reason. So if you give public IP address to a virtual machine, it has access both ways. It can talk outside and it can listen inside, right? You don't want the machine to go outside. You want the machine to go outside, but no one to come in, right? So this is where it really becomes important. And why would you want your machine to go out? To update its packages, to be able to get data from the internet. But no one should be able to reach out from the internet. So this is where NAT gateways are really useful. Because if you do not give public access to your machines, they will never realize that they are outdated or they will never update themselves. So to keep them updated, you have to give them internet access. So you connect them to the NAT gateway. So it is just one-way translation. So your machines can go out, but no one can reach back to your machines because there is no way to come back. Again, there is still a problem, but later on we'll cover that. It just allows you to go out. That is again an exfiltration problem. Let's say your attacker has reached your machine. Now it has access outside. It can exfiltrate the data. This is really interesting. If you gather up all of the cloud information, cloud knowledge, or like multiple cloud providers, there is one specific problem that exists almost everywhere, which is data exfiltration problem. no one has really came up with the technology or with the method of stopping data exfiltration or controlling data exfiltration. Everyone has a lot of senses of like web application firewalls, IDS, IPS, a lot of things in terms of traffic coming from the internet to your network. But very rarely can you control the data going from your machines to the outside. You have egress controls for sure, but it's not really powerful when it comes to
For
data
corporate
exfiltration.
networks, we have like this SSL inspection,
Yes.
but for cloud networks, that's not an option.
It becomes very complicated. Yes, the egress controls are really complicated, and this is where I was saying that Google has done good. Google has come up with one thing called VPC-SC, VPC service controls. This is a very I haven't seen this in any cloud providers. This is a technology that allows you to control the risk of data exfiltration. It very specifically whitelist one particular API for one particular bucket. So with this VPC-SC, you can say that this machine is allowed to talk to Google API or Google buckets, but only this specific bucket in this specific region in this specific account, right? And it took me a long time to this is a very new technology, at least when I was using it. Now it is something that internally Google is using all across it. So I had the chance to see how internally they have created their network. Internally, VPC-SC was one thing that was wrapped around everything. So it's a very technology that they are selling you, but they're internally also using it. So it's really powerful, but very complicated. Like it is one of the most complex pieces of cloud security in GCP that you will end up with. And every cloud security engineer interview will ask about it. So you will have to learn it if you know. It is kind of egress filtering, yes. It's like a first cloud provider giving you egress filtering, but on steroids in that sense. Because it allows you to do egress filtering on APIs, it allows you to do egress filtering outside your network also, and on the private networks also. NACL? It's complicated, you know. And with NACLs and other, any technology that you put in, you have to make it cloud compatible, and you have to make sure that it understands the network traffic, it understands 15 different machines that you have. I'm not saying that it was not possible. I'm saying it was complicated to implement it, and there was no cloud native solution before it. The first cloud native solution that I've seen is from the GCP side. At least other providers haven't come up with a cloud native egress filtering solution yet. So it does not mean that it cannot be done, for sure. I mean, companies exist, they must be doing it. All right. CloudNet, simple, NAT gateway on cloud. You don't really need to worry about managing the IP address, managing the virtual machine, patching the virtual machine. It's managed. It's a managed service from the cloud side. Not much fancy things there. The whole difference between a normal NAT and a cloud NAT is that cloud NAT are managed by Google. Normal NAT gateways are managed by you. So you are responsible for patching the virtual machine, making the IP address running, and doing all sort of maintenance about it. Very simple diagram. So if you look inside, this is subnet. So virtual machine with IP3, it can reach out to external host. It is allowed. Same IP5, it can reach out. But external host cannot reach inside, right? So it's just one-way translation. Cloud VPNs, we have already talked about it. It's point-to-point connections, right? So when I connect my company to other company or my company to the cloud provider, now this is where it gets really interesting, that the traffic goes via the internet, but you can almost call it private, right? The VPN tunnels go via the internet. They are always meant, the traffic always go through the internet, right? VPN, when you connect your VPN, NordVPN or whatever, it goes via the internet. But from this point to this point, there is no way someone can listen to it. So it's the only way when you are diverting your traffic through the internet, but still making it private, because it's end-to-end encryption and end-to-end tunneling. So no one has the visibility to see through it, although the traffic still goes through the internet. So in that sense, if you look at this one, it's encrypted tunnel to on-prem. So basically on-prem is my company, let's say this office. So I connect a VPN tunnel from here to my cloud provider or my VPC. Now VPC was a private network, and I've connected my internal company network to it. So the traffic is going through the internet with the private encrypted tunnel. Problems are there for sure. It is because it goes via the internet. and internet is used by multiple people, your bandwidth is not really good. So it's not a company grade thing, right? So you're not the only one running on the internet. There are multiple people doing it, and then internet goes off, and then there are a whole lot of problems on the internet. So it's not a company grade solution. For that, there is something called HAVPN, high availability VPN, which is just the second option of it. So a VPN tunnel, how does it work? You connect one point to the other point with one tunnel. With high availability VPN, you have two tunnels, simple as that, right? So one tunnel goes down, you can use the other tunnel. So obviously, because there are two tunnels, your bandwidth increases, your chances increases, your overall availability also increases. That's why the number is 99.9.
And the cost?
Also increases. um, it's a so in terms of exam, whenever exam is asking you, I'd say VPN is your answer. Simple as that. So VPNs are not company grade. So whenever they're asking like private network encryption or whatever, your best shot is to use HAVPN. If you're seeing the option of HAVPN, this is probably your answer in terms of VPN. There are better options than VPN, but in terms of VPN, always use HAVPN than legacy. There is no way you should be using legacy VPNs. Cloud
When
interconnect.
you create a VPN, it gives you this option which type to create.
Yes. Yes, when you create a VPN, it will ask you to you can enable the mode. So you can basically create a VPN tunnel and then upgrade it to HAVPN, or you can from the start create two tunnels. But it's going to be essentially very similar. How do you set up a VPN tunnel? On my side, let's say I'm connecting to Muskan's network. So on my side, I will create two IP addresses. On her side, she will create two IP addresses. Then we'll exchange the certificates, and then the tunnel will happen, right? She has to approve, I have to approve. There will be two tunnels, and then we will route our traffic through it, right? So it's like we can do it on the labs. Cloud interconnect. This is as simple as that. So one major thing that I was emphasizing in the last slide was that your traffic goes through the internet, right? In cloud interconnect, your traffic does not go through internet. It goes through private network. How is that possible? You literally create a private network or private route from my company to the cloud provider. How is that possible? So you reach out to your ISP, your internet service. Sorry? I mean, yeah, technically in the background, they will be implementing it. I don't know how they're doing it in the background, but I know how it's set up on the practical implementation side. So you reach out to your ISP providers or wherever the Google's last network is. Google, interestingly, is one of the only private companies, who is also an internet service provider, right? And they are tier 1 internet service provider. What do I mean? They have their own cables from one continent to the other continent. That's a very rare situation with companies. Private companies do not have this much of investment. Google has it. So the idea between interconnect is that to the very last point. So from here, my internet is coming from, let's say, Tele2. Tele2 is my ISP, right? So, and let's say Google or Amazon that is the last point where they have control over. So you reach out to your internet service provider and you tell your internet service provider that from here to North Virginia, where my data center is, your AWS data center or GCP data center is, you go and say, make a private connection to there, because they have the wiring, they have the cabling and everything. So they will dedicate a private route to you for it. So it is actually you talking to your internet service providers or your companies or your basically internet companies, and they create a dedicated line for you that you can use, right? But it is dedicated. They do not ensure encryption on it. It is because it is private by the service of it. Once it leaves the Google network, it does not care about the privacy of it. So it is your problem to take care of it, right? So it is private network to the point no one is on your network, they won't be able to say it, but you still need to care about the privacy, like the encryption side of things. And a lot of compliances, ISO 27001, SOC, whatever you will talk about, HIPAA, everyone wants your in-transit traffic to be encrypted. So how would you solve that problem? You will create an internet interconnect from your corporate to the data center, and then you will run a VPN on it, because VPN made it encrypted, right?
How does the ISP allow by allowing the IP address? How they enable it?
That is their physical infrastructure that they use. So Google as a company or AWS, this is not also Google specific, everyone does it. companies, they collaborate with local ISPs, and they run from their data center to the ISP provider. They run their cables. So, and then they make sure ISPs give them the service. Of
It's just like agreement. We don't.
yeah, it's agreement. We in the background it is implemented. Yes.
Yeah, but if, cables, so it means it's a physical security and Google and AWS, they provide security on this level. So, but why they can't implement?
Yeah,
encryption? So, yes.
I see your point. I see your point. They can for sure, I guess, but I guess it's more about liability, because technically Google has all of the control, all of the physical, legal, actual control to the point that is their premises. After that, once the data is on, let's say, Tele2's network, then it is just legal agreement between them, right? So that is why they take their liability back, and they're like, it is Tele2's problem, because if they do, then they have to make sure like customers can go back and sue them, right? So it's more about legal side rather than the actual technicality of it. Technically they can, but because legally if they do it, there's a high chance that they'll be sued back or they'll go wrong or whatever. That's my reasoning, or that is what I have seen. Why my understanding based on some internal data center guys I've talked to, this is what I think is the situation. But I think they can do it. And there are like multiple versions of interconnect. There is dedicated interconnect, which is like physical cable running from last provider, let's say the ISP of London to the ISP of North Virginia in US. So obviously it is costly. It depends, like how much money are you willing to pay? This is where, let's say, KPMG India is connecting to KPMG UK, because they cannot take the risk of like someone interfering in between. So when companies want to connect their headquarters, and there is like a huge amount of data also, we are talking about 10 Gbps to 100 Gbps of data being transferred from one end to the other end. So this is where you would want a dedicated route to it, right? But with VPNs, the speed was, where is that? Somewhere it might have written it. Yeah, throughput. Where is? I think I lost. Oh, yeah, 3 Gbps. Lost my vision probably. 3 Gbps. So that's the speed you get on the VPN side. But if you go to the interconnect, obviously you get a better speed, 10 Gbps to 100 Gbps side. There is like the gotcha I told you, it's not encrypted. It is your problem to make it encrypt. So you basically set up the physical route and then you run a VPN on it. That basically does the encryption component, right? So you're good there. From the exam perspective, this is, like you can already see, this is not something that normal customers would do. This would be done by very big companies, and more often than not, just two big partners or two really big corporations. And from the exam perspective, you need to know that this is not always the answer to the point VPN is connected to it. So if you see an option of interconnect, let's say they say that two business units of a big corporation wants to connect to them, VPN cannot work. VPN is the wrong answer. Interconnect is the right answer, but interconnect is not the right answer when they mention compliance to it, because compliance will fail because it's not a encrypted network. So to get the right answer, you need to have interconnect plus VPNs associated to it. That's where it becomes like good. Otherwise, compliance fails. You need break, or should I go? Okay. Cool. Hey, we can take like 5 minutes break. It's okay.
No, that's just me.
Anyone else want to go? Okay, cool. Yeah.
You do this on your way out and
Okay.
come back in that break for Sarah.
Know where it is? Or
Do you know where it is?
I know where it
Near-
is.
near the
Ah,
left.
okay.
Have you used IAP? Have you used IAP?
But it's cognitive. I'm sure
Ah, come on.
it is. It's cognitive.
It's not. It's not.
It's not exactly, but it is like some of the features that it provides.
Network security exam. Just anticipate.
Oh, finally.
Yeah.
Yes, so I think everyone is aware of skills.cloud. So if you go to, for you, Nadia, skills.cloud is where we are doing the practicals. So it's like a already done session for specific technology. So you go in there, it's like a well-structured lab. So you just open it and it has everything that you can do. If you go to the skills.cloud and search for IAP, IAP, that is Identity Aware Proxy, you will see one of the labs that is securing cloud and identity aware proxy lab. You can start doing it if in case you are not interested in the theory, or you can listen to it side by side and you want to do it on your own. But it's a bit of complicated one. IAP is specifically the technology I was saying. It's not much there on different clouds, so maybe it's better for you. But if you get the chance, I'll definitely do the practical of it. But let's go through it for now. With the IAP side, so we talked about what we have just covered to this point is that you can give access to Google services via Google Private Connect, and you can just enable a certain toggle and your virtual machines will access it. This was one way. And then we talked about VPNs, which was allowing your corporate to connect to the cloud in a private way, and then interconnect, which is like a dedicated channel. In all those scenarios, there is that is good, but they're not zero trust situations, right? They are all in the sense of very traditional situation happening. VPN is not zero trust. Why? Anyone want to guess? Like why VPN is not a zero trust? Sorry? No, that's not. No.
Basically, mainly trust and network-based trust. Like if you connect it to the VPN, you are trusted. Like your request is valid. If not,
Yes, both of them together. So it's a private network. That is, once you are connected to a VPN, you are inside. There is no authentication. So that means there is no one checking it. So that's why it is not zero trust, right? So now we want to talk about the zero trust side of things, like how we can do that. IAP, Identity Aware Proxy, is one such situation. What it does, it's a reverse proxy. There are two types of proxies in a theoretical sense, forward proxy and reverse proxy. Muskan, you want to try? Forward proxy and reverse proxy. I explained it to you.
So start and then I will continue.
It's okay. There are two types of proxies in a general sense, forward and reverse proxies. The difference is yes.
It's kind of a relay server kind of a situation where if you want to talk to some other server, you are a client or something like that, and then you are gonna talk to one server, and then that server will forward your response to another, and something like that.
Yes and no. Somewhere. Let me try to explain it from the application or the server perspective. So two ways, forward and reverse. You have application and you have client. Depends where the server is sitting. So if your server is sitting close to your proxy, if it's sitting close to your server, then it's a reverse proxy. If your proxy is sitting close to your user, then it's a forward proxy, right? What does it do, and what's the point of talking all about this? Forward proxies shield your identity and your application, and they're the one who go on behalf of you and do everything. And this is not just about internet traffic. It has more intelligence than just a NAT gateway, right? NAT gateway is just basically shielding your IP address from private IP to public IP. That is the only thing NAT does. Proxies have much more intelligence on the application level. So it can decide what goes out, which websites you can visit. If you're working in big corporates, you must have seen this. Certain websites are blocked, right? And sometimes you go in it. Sometimes it asks that you need to prove that you need a business use case for this website, and it does it on run. So they cannot like whitelist all of the websites, right? There is no one sitting in the background, a security engineer who is saying like, okay, not okay, not okay. There's no one is doing it, right? So this is a forward proxy situation, which is basically the traffic when it originates from your laptop and goes out to the internet. The proxy analyzes it, and see if you need it or not. This is very simple version of it. This is the most obvious and most simple implementation of it. It can go in much more depth and much more intelligence. Like the context intelligence I was saying will come in place here. But of proxy is basically analyzing your traffic on the application level and making some intelligent decisions and deciding if you should talk or not. And similar way, this was forward because it was sitting on your laptop and it was basically intercepting your traffic and then deciding if you should go out or not. Reverse proxy is something that is sitting close to the server. So let's say you all are trying to reach out to me, which I'm the server, and there is a proxy sitting in front of me, right? So this proxy will intercept all of your traffic and then decide if it should come to me or not, right? So this is a very general explanation of proxies. Proxy is a very old technology. It's not new. If just by the definition what I've explained, you might have understood that this is not a new thing. A lot of tools do it. Web application firewalls at this point are also doing the similar situation. So it's you can put even, in fact, a WAF could also be a reverse proxy, right? So it's a very bucket term which you can use. Why I'm blabbering all of this. So IAP is a reverse proxy, right? The component where I said proxies are more intelligent. This is in generic. If you will try to put it into a technology bucket, it will fall into the reverse proxy situation. It has much more intelligence. In that sense, it has IAM entity, IAM identity information. It has context information, and based on that, it decides if you should be able to reach to the server or not. Reverse proxy, right? So reverse proxy was sitting close to servers. So when you enable IAP, this is the shield that is enabled in front of your applications, right? Front of your servers, your web applications, your Kubernetes servers, or whatever. You enable it, and it becomes a reverse proxy for those. And what does it do? It has the information or understanding of everything that Cloud IAM has. Cloud IAMs are powerful, right? Previously, you did not had the option to be able to use Cloud IAM for the authentication of normal users coming from the internet. So IAM was used previously also, but it was for cloud administrators or cloud users. But people who were coming from general internet, like normal people like us, you can use IAM, Cloud IAM with them, right? This reverse proxy allows you to do that. What do I mean by? You can authenticate the user. You can ask them to authenticate. You can put IAM roles to them. You can put a general IAM role to them, that is this user allowed to access my service or not. You can put in context information to them. Where are they coming from? This is where the zero trust component comes in. Putting all of them together, not just the context, right? What did we just talk about in the start of the session? What is the zero trust component? You need to authenticate and keep on authenticating every time you reach out, right? Now you have IAM sitting in front of your servers for the normal internet. Whenever they reach out, it always makes sure that your cookie is alive, or basically you have authentication done properly. And then you have authorization, which is IAM role associated to it. What role do you have for this server? So this is where the IAM component comes in, the authorization component. And the last bit is the context. So every time, let's say I am authenticated and I take a flight, go to India, it will realize that my location has changed and it will deny, right? So three of them put together is what IAP is able to do.
What if it's not a user that's trying to come in?
It's a user-facing thing. It's not for the applications.
For public traffic, it doesn't allow public traffic to come in?
No, public traffic is fine. You can, so I said in the authorization side, I said you have to assign a role, right? So you can assign different roles to different users. That is where it becomes intelligent, right? So if the user is authenticated, then you can assign a certain role. If the user is coming from this organization and has been authenticated on Intra ID, you can assign a separate role. And if it's coming from the public internet, identity layer is added. Yes. The identity.
Looking at an IP address.
It is.
It can as
as
part of the context.
Exactly, yes. So it is looking at the context also. It is looking at your identity also, and it is looking at your role also. Together, it is making a decision if you should be able to do it or not. The zero trust component is where, let's say, your identity is right, you have authenticated. Your role is right, you have the role to it. Your context changes. I logged into it, and now all of a sudden my laptop is in Russia. Now this becomes a problem. The context has changed. So you cannot do it. Or someone tried to change the role. right? Or because at the end of the day, it is a JWT that is being passed in the background. In the JWT, I try to change the role of it. It will realize that someone is trying to manipulate it. It will fail. It becomes intelligent, and you can do this internally for your own services also. So when your service tries to talk to the other service, you can do that. I haven't done it, but it is something that this is where I'm confused a little. Maybe this was internal Google situation where they were doing it with services, but publicly you can do it for the internet also, right? The service that we know, it can be used for like general public. I think they're extending it to do for the service to service communication also.
How do you enable it? Is that like a service attached to a role or attached to a VP? Sorry.
VPC.
Not, yeah, VPC or virtual machine. How do you enable that?
Yeah, it is.
I didn't do the lab, but I need to do it in order to learn. But
Okay.
how do you do it?
No, it's a good question. You do it for the service. You don't do it for the VPC. So it is not enabled when you enable IAP. It is not enabled for the whole subnet or for the whole VPC. It is enabled per service basis, right? So let's say I created a server on which where my website is, or I created a Kubernetes cluster where my application is, and that way I have like 15 different applications. So IAP is enabled per application. So there is a specific portal where we will go. Problem is I'm sharing it from the different browsers, so I need to move my browser from here to there. Maybe let's do that. Okay. Yes.
It's a Google profile.
Yes,
Yeah,
it's
different profile.
it's my own like website profile, like own Google domain.
I'm not seeing it yet.
No?
On Google Meet.
Yeah, Google Meet, you won't be able to see. I didn't share the full screen there. I think I can share it again. You can try sharing the entire screen. Yes, this one works. I think it should be good now. Perfect. Okay. Yes. So the service name is IAP, that is Identity Aware Proxy.
What's its equivalent in AWS? Do you remember?
Yeah, that's where it gets tricky. I don't think there is equivalent of
I
it.
have a question. So the Google skills thing you said to the practical side by side. Which lab were you talking about?
You see it in front of you, this one.
This is your account or your company?
The first one, yeah.
Secure cloud application with Identity Aware Proxy. If you haven't, you wanted to use the IAP, right?
Yeah.
I think this is a really good lab. Even if you guys don't do other labs, just do this one, because IAP is a new concept. It took some time for me to understand. So I'm assuming that you guys would also need some time. So even if you don't do everything, just do this one. You will have a good understanding of what IAP is, right? It's a good lab. And you can do it too and let me know if it's cognito or not. Dida, you were saying what is the equivalent of it in AWS? Ujjwal thinks it's equal to cognito in AWS. I don't.
Cognito is identity.
Not exactly similar, like some feature of it, at least the way it provides the identity in that sense, yeah.
Yeah, I mean, I don't think so. The identity component, yes, for sure, but
Yeah, it's not exactly similar, just few components.
Yes,
Like you're
yes,
saying
yes, yes.
everything.
yeah, for sure. The identity component is definitely cognito. Okay, so this is where the IAP is. And because I have not deployed any services as of now, so it is not telling me where to enable it. But this is where you will go and enable your IAP service. When you create a particular application, you associate it to load balance or whatever, it will start popping up here. And here you can click on it. And then this is the part where it will come up with like enabling the IAP component of it. I need to deploy something and then I can show you here. But this is the console. Because we are in the application section, it is asking me to connect a new application. I can in fact connect this to my on-prem application also, right? But when I do, once let's say I create a virtual machine and I expose it to a load balancer, it will start popping up here. And this is the tab where I will go and enable IAP. Right, just enable it. And on the right, you will get an option to assign a role to it. and the identity to it. I think we need some time to like actually show it to you, like do the actual configuration. Once I'm done with the theory, I can go to the lab and actually show you how does this look. But
So you would add resource by resource.
yes, so it's a really interesting and good question, because let's say you have Kubernetes, and Kubernetes, you can have 5 different applications. So you will not enable it on the whole Kubernetes cluster. You will enable it per application inside the Kubernetes cluster, right? So you don't enable it for everything. You enable it one by one per application per service basis. And there is other side also, which is SSH and TCP resources. So you can enable this for your virtual machine, and you don't need to have private IP, and you can have an SSH connection. Now, this is a magic to me. When I first saw it, I was like, what? How did it happen? So what I'm saying is, you have a virtual machine which does not have a public IP address, and you're able to do SSH connection to
This
it.
is the internet, right?
With what?
TCP, SSH is connection through internet. So
Yes.
You need a public IP.
Yeah, you didn't need, but you don't. So this is where it becomes like a very magic situation, that how is it happening, right?
So my
It's
company
in the wind.
enabled that, but I never knew how it worked and who did it. So now I know.
Yeah, and you still need to know what specifically is the thing, because it took me some time to realize what they have done. So let's say you created a virtual machine, it will pop up here, and you enable this, and then from your laptop, you go with the G Cloud, you type G Cloud SSH virtual machine name, and it will connect to the SSH connection to your virtual machine. There is no public IP address to your virtual machine. There is no SSH whitelisting. In fact, you have done. You can still do it.
What do you enter to connect to SSH, like surname or IP address?
It understands because you're using G Cloud utility, Google Cloud utility, and you have authenticated yourself to Google Cloud with that utility. So it understands the name of it, name itself, right? Instance name, metadata name, right? That is because, and I understand your question, because SSH needs IP address. So you don't need an IP address because you have authenticated yourself, your laptop to Google Cloud. So technically your laptop knows what your.
So it's like connection, SSH connection to Google.
Yes.
Okay.
Yes, exactly. This is where it gets interesting. So what they do is, technically how this works is, you create a virtual machine, you enable IAP here, and if you try to do it, it will not work. But then there is this IP address list. There is a, let me check if I have it open somewhere. AP.
I go back, I will check the settings to see how did they enable it? What are the rules and roles?
Yes, you will see this CIDR range being whitelisted. Here it is. 35 235 240.0/20. So this is the CIDR range that Google has exposed for IAP internally to everyone, right? So what they do is, from your laptop, when you try to type Google G Cloud SSH with this virtual machine, it creates a SSH connection to the last endpoint it knows in the Google Cloud. And from that Google Cloud, because it's a private network, you have to whitelist this, and from that it makes SSH connection to your laptop, to your virtual machine. So for your eye, only your laptop has public access, and your virtual machine never has public access, but you're still able to do SSH. And from the compliance perspective, is the best posture that you can think of because you don't associate anything to ever. It's a really, like, I know it's a very eye magic situation, and I had like a lot of debate about it, but I think it's a really good way how they do it.
So you can really connect to Google Cloud components. Right?
Yes, it's just Google Cloud. Yeah. I think I got your question wrong. What I mean by Google Cloud is that your virtual machine has to be in the Google Cloud.
No. My question is from your Google Cloud, and I'm assuming that the SSH connection is to a service in Google Cloud only, or it can go outside the internet.
You are making SSH connection to your virtual machine, blank virtual machine, no service or anything. You created a virtual machine and then you enabled IAP on it. From your laptop to this virtual machine, you are doing SSH connection without having a public IP address.
To my laptop. Okay.
Do we need to create a public and private key before it goes to SSH?
No.
Okay.
It does it via HTTPS.
Okay.
It's really like it takes some time to understand, And if you go back and see for your company, you will 100% see for the virtual machines, if you're doing a private SSH connection, you will 100% see this IP address being whitelisted. And if it is, so this was the one that I just showed you is for the SSH slash TCP connections to your virtual machine. For the application, it is different. It is the first step. That is where I was saying for virtual machines, it is making TCP SSH connection via HTTPS. For applications, it is a reverse proxy situation, which uses identity aware context and all that situation, right? So I know because there is nothing here, it is really hard to explain. I need to create some resources and then probably show you. But overall, that's the main idea here. Let me go back to the slides and complete it so that at least we have the theory done. Yes, so there are two modes you can use: HTTPS resources, which protects your HTTPS load balancers; App Engine, GKE, which is basically different services that you can create, right? The way you can create applications inside your Google Cloud. And the other is TCP forwarding, which is SSH RDP tunnels. You can do RDP also without having a public IP address. Now think about it, which is like I have personally never seen other than GCP people doing like RDP connections without having a public IP to your Windows server.
What's RDP?
RDP is remote desktop protocol, which is basically you do SSH to Linux machine, you do RDP to Windows machine. It's a different protocol, but doing the same thing, remote control.
Very old,
But still being used very,
very much in use.
yeah. I disabled it today on one of the systems. The problem is it's not as secure as SSH. The most used version of RDP is via passwords, ID and password, right?
And it can be brute force.
Yeah, that's the
So
problem.
You should never have internet-facing RDP service.
Yes. And developers think it's a good idea to have it, which is, I mean, I don't mind, like, developers have their own reason for it. The thing is, like, they deploy virtual machines in non-prod subnets and then they expose it to the internet. So they think that there is nothing on this machine. If it's compromised, no problem. Problem is if it gets compromised, the rest of the subnet is compromised. And all of a sudden the attacker is on your network. Anyways, let's go back to the solution. And if anyone who is listening after the call, I'm not against developers. Sorry about that. SSH into a VM with no, sorry, the magic trick is basically you can do the SSH to the virtual machine without having a public IP address. And like I said, you need to whitelist this IP range to actually do that. Exam focus IAP, obviously, it is very opposite to perimeter security, right? You do not, so I just explained why VPN is not zero trust, because you connect and then you're flat. It is not the case here. When you connect with IAP, your identity is being checked every single time you are going to the network, right? So it checks if your authentication was done properly, and if your authentication is 3 years after, or 3 hours after, or basically whatever expiration you have set, it will ask you to authenticate again, and then it will check your role, which is like the authorization component, and then context and everything, and blah blah blah, right? So that is why it's the zero trust component. So this is the diagram of it. So this is a user. This is the identity aware proxy, which is like a reverse proxy. You authenticate with Google sign-in, which is Google sign-in is just one component. You can connect anything. I personally have deployed it with Azure Intra ID and Okta. So I can give you an example how I was doing it. So my company previously was working with one of the big pharmas. So they didn't want to create user in google.com because my company was in Google. So they were like, we don't want Google email IDs and we will not create users in your tenant. So they wanted to use their own users, which is, let's say, xyz.com. So they wanted to use their own domain name and own user. They didn't want to create their own users. So this is what we did. I created the application that the application that they wanted to use. We created that in one of the Google projects, enabled IAP on it. And then where you're seeing Google sign-in, I enabled IDP, that is identity provider, and then connected their IDP to it. So every time they wanted to access our service, they will come to the URL, they will authenticate with their normal users, with their intra-ID users. And once they come in, authorization component is where I will control their access via Google internal roles, the roles that I created, right? The Google Cloud roles. So they will authenticate on their identity provider, come to Google Cloud in IAP, and this is where I will assign some role to them. And I assign some role to them. This is how they decide that if they can access the particular service or not, right? So this is how and this is a very good use case of why IAP becomes powerful, because we were in Google, Pharma didn't want to interact with Google. So this is where we give them a surety that you can use your own users. You don't really have to create users with us, and you don't have to share your PII with us. You can still be in hold with them. And we can expose our services to them and have zero trust on it. You authorize, and then App Engine / virtual machine / load balancer / whatever you want to put behind it. Access Context Manager, simple service, like I said, nothing much here. It just basically checks every context possible. So it checks the posture of your laptop from which you are trying to access, your location, your IP address, your CIDR range, which OS version patches you have, blah, blah, blah. Basically collect all of the location context and all of the context possible. The more context you can give it, you can install an extension in your Chrome browser, and it will collect more information from there. You can install an agent on your laptop, it will collect more information. Depends how much context you want to give it. And then you create a policy against it that if the user's laptop is not having patches for last 7 days, the user is not allowed to access, right? And you can do this with IAP, right? So IAP is the rule checking engine. Context Manager is the one where you collect the rule information, the user information.
So is that a service as well?
Yes, Context Manager, the one Deezer was
You need to
explaining.
configure it, or like,
Yeah.
does it already have some inbuilt?
It has
policies?
policy templates you can enable, but so it's a two-way thing, right? So there needs to be an agent that collects this information, and then the policy engine where
Yeah.
it's being parsed.
Checked.
Yeah. So IAP is the engine, and Context Manager is the service that brings this information to IAP. But for the Context Manager to collect this information, it will collect some things from the header, HTTP request, and everything. But if you want to make it more efficient, you can install a like Chrome plugin. You can install a agent on your laptop. It will give more information. But yes, that's the case. Private Service Connect. Okay, let me go back and see what is there. Okay, this is the last. Fine. So IAP again. I think you got the basic idea. It's a new service. If you are still confused, don't worry. I was way more confused than you probably are. So it took me like a whole POC for Google to actually prove their service, that's how it works, to understand how it actually works. So there is no alternative, at least for me, rather than doing hands-on. Go back, do the lab, you'll get much more idea. And it's a very interesting service. So the last one for this session is Private Service Connect. We already are talking about multiple ways how you can connect privately. Now this is the one, again, not Google specific. You can use, there is a flavors of it existing in different cloud providers also, which is that it is from your VPC to other VPC. So the idea is basically it maps your private IP from your VPC to a service published elsewhere. Now, elsewhere can be anything. Elsewhere can be Google. Elsewhere can be you being my customer, and elsewhere can be a vendor, right? So let's say Datadog is the utility I use, / whatever you want to call it, right? Curadar or whatever, right? I want to use one of the services. Now, let's say they are also in Google Cloud. So they can, the Datadog and I can use VPCSC to use their internal service directly via private IP address. The logic is again same, that because they are also part of Google, I'm also part of Google, why go to internet? We can directly talk inside Google network, right? Logic is always same. If you will go behind all of these technology implementation, you'll always figure out one simple logic, that it is using the private network to do all of this, right? Private network of Google, right? Now, Google has given you different configurations on how you can do it. If you want to use like specific IP address ranges, then IAP is for you. If you want to use all of the internal services, then you have Google Private Connect. And if you want to use like your customer particular service, then you can use VPCSCs. Oh, sorry, Private Service Connect. So let's just there are three different flavors of it. So let's talk about the first one, which is Google APIs. You remember we were talking about Google Private Connect previously, that you can use the internal service also. But when you enable that, I said when you enable this particular toggle, you are able to use all of the Google services internally. Now, what if you don't want to use all of the services? What if you want to use just a specific Google service, or you want to use the IP address of that service? So this is where this comes in. So it allows you more control of which particular service is enabled, rather than you enabling the whole public IP or private IP suite, that is private googleapis.com. You enable buckets.googleapi.com, whatever, right? So one specific service, one specific service.
Private service connect and private service access.
Uh,
The one that you said.
no, private service access, the one that we studied in the start, it enables access for all of the Google internal services. Here you can enable it one by one for a specific situation.
So this solves the problem of the attacker having
Still not.
Yeah.
No, because
but
you
they can still make the bucket.
yeah, because you still are enabling access to one, like to whole of the Google buckets. You didn't enable access to all of the Google services, but you still enable access to all of the Google buckets, or basically Google Bucket API. That problem is solved by VPC-SC, VPC service controls, the one I mentioned that controls the egress or data exfiltration risk. That is a separate session. I'll explain you how that works, but there is a way you can control that also. The next one is PSC to publish services. That is when you have a service like in different organization, basically a customer, like let's say you're a customer, I'm a customer. In your VPC, you created a service that you want to sell it to me. Why make it public? You can through through Private Service Connect, you can create a private IP and a domain that I can directly use inside my private service or private network. It seems like really like superficial, but try it. It is, I think this is the last service I've seen people using. I don't know why. I myself haven't come across this, because it gets to the very last of doing like network security and network architecture situations, but it is a really powerful one. I've
When you
seen
say-
one use case where people were using it.
So when you say customer to customer, you mean a different organization?
Yes.
Okay.
Yeah.
But they both should be in Google.
Yes. PSC for third-party SaaS. This is where like vendor exposes their service to PSC, so it consumes it without going through the internet. That is basically vendors, right? And I don't want to comment on this particular sentence, but I think there is a way that you can do this on other cloud providers also. But I am not super sure about it. I remember my manager asking me this, and we never went ahead doing it. But I remember that I saw some way of doing it. Maybe this was the use case, but I need to go back and check. But for sure, internally, if they're in the Google, you definitely have the options to not go via internet. Yes, now I got the reason why people don't do it is because they end up creating peering connections, VPC peering, because that's the easiest, everyone knows. So they will create a VPC peer from their private from their VPC network or subnet to their VPC network. But that is not, I personally handled that chaos, because at some point there were so many VPC connections that you cannot figure out what is actually connected to what. So this sorts out that problem, right? You specifically expose one particular service, and how does it do that is it in AWS, how they do that is through, what is that, Elastic NIC, network interface card. So it creates a NIC inside your subnet and assigns a private IP address to it and register this NIC information to Amazon global DNS. Right. So internally, this is how it's implemented. Basically, the idea is that you register your service to Amazon's list, and then from there you know how to connect.
NIC is just.
Network interface card.
Missing traffic, no?
No. It's a legit hardware. Every laptop has it. It's how you connect to the internet. No. It's
the bit in your not even motherboard.
So
But when you, we used to, put
RJ45.
cables and that we directly connect to the NIC, but now, like Wi-Fi, and if you need, it's the network component of your laptop.
Yeah, it's a hardware component that almost all devices have. Like the one either is mentioning, it's RJ45, which I haven't used
have
for
it?
now. I don't have it.
Because the post offices, laptops are quite.
You look at the Ujjwal's laptop, he opens his all the time, right? So where the RJ45 is, the chip there is called NIC, network interface card.
through which all the network traffic flows from your computer to the website server.
Yeah, it's not for sniffing for sure.
It is used for sniffing also,
Yeah,
right?
that's fine.
Yeah, because
process
it's
is
the only
more-
point from where all the network is going, so you can
Oh,
put
so-
some sniffer over there to sniff.
Yeah, it's used for sniffing because this is the center point where every traffic is going. So you can use it, but that's not the use case of it. All right. Okay, the last best practices of it: do not use public IP address. That's the whole point of the session. Right? Use, if it's outside, if you want to make outside connections, use CloudNet. It will allow you to mask your internal services from there. If it is about keeping the traffic internal, private Google access or PGA, this is where it gets really tricky in the exam. If any of you decides to give the exam, you really need to, like, what I did was just before the exam, 5 minutes before, I wrote down all of the names of this private service connect, PGA, and all those, because they will just give you this acronym PGA and you will forget like what is it. So I just like brute forced it. So
Yeah, you really need to do the labs on this to really understand the concepts, because they're also similar to each other.
yes, it is. Like I was saying initially, when we were starting in this series, it was fine even if you just listen to me and not do it. The more we are going in, now it's getting very specific to Google Cloud. So your other cloud provider knowledge is not enough. If you really want to know it, get hands-on now. Modernize the parameter, use IAP. That's the whole idea. Basically, don't use bastion host. We have talked about why we should not use it. IAP should be used. Why? Because it has identity aware proxy, like it has context information, it has IAM bits to it, it has authentication bits to it. So you can basically use much better component of it. When it comes to hybrid connections, in terms of VPN, you should always, if you are seeing an option, you should always be using HAVPN, which is high availability VPN, two tunnels rather than one tunnel. This is always the answer. And if you're using private service, what was that? Interconnect. If you're using interconnect, it in itself, it's never the answer, most probably. Whenever you are seeing the answer as interconnect, you need to use VPN alongside it because it does not provide encryption by default. Enforcing the context, access context manager. To be fair, in fact, Google was not using it. So it's a complicated one because it takes time. But now, because so I'll complete this. So if you are using like if you want to have like context, if you want to make it like context rich, this is where the context manager comes in. It takes all of the information from different devices, puts it together. This is how you make the whole decision. Session is complete in that sense, in sense of theory. There is one last bit I wanted to talk about. So the way Google has created this is actually from the use case they created, like the whole, like for their own internal things, right? Have any of you used Chromebooks? No. So the idea of Chromebooks is that it's not a laptop, it does not have anything of its own, and it's just a terminal. So the terminal in the sense, just a browser. So it's
The
a
browser is the operating system.
yeah, exactly. So they created this and then they created context manager. So they wanted to use Chrome like a context information, and they realized that now we are getting to the point where laptops does not really hold anything. So if everything is shifting to the cloud, then Chrome is becoming really powerful. So this is where they developed a plugin. Internally, this is the story of how they ended up here. Let me stop recording it.
But before I stop recording, I asked Copilot if AWS Cognito equivalent to GCP's identity aware proxy. The answer is no, because Cognito is an identity provider. but IAP is an access enforcement layer and is a reverse proxy. So they don't do the same things. I can put this into notes as well.
Okay.
Now I will stop the recording. Give you a
Yay.
second.